Okay, good morning everybody. My name's Richard Johnson. I'm working on a PhD with Professor Martin Mayfield and Professor Stephen Beck based around electrical energy storage in urban systems. So let me just try and give you a little bit of a background on why we're doing this project and what it's about. So we talk a lot about energy storage and where it should be located, and particularly where it should be located on the distribution system. So should it be at the household level, at the feeder level, at the secondary substation, primary substation level. But although there's weight to a lot of the arguments, it's largely unquantified. We haven't really looked at the numbers and the sizes that are required to provide certain services. So if we want voltage control on a feeder, where do we put the star? How big does it need to be to provide this adequately? What location does it need to be in to even be able to provide this service at all? And this is likely to be a property of PV penetration and electric heat penetration. So if you've got a lot of heat pumps, it might change where you want your storage to be because you get thermal violations along a feeder. So my project is basically based around the idea of looking at different penetrations of renewable technologies and how this is going to affect where storage needs to be to provide particular services. So how do we do this? I'll just give you a quick rundown of that. So SSE have been kind enough to provide me with some data on medium voltage networks, so I'll be using that to build some OpenDSS models which I can run power flow simulations on. I've already got, oh, has it just kicked in? Oh, so I've just been able to get hold of some low voltage network data from Manchester, which I can use to run simulations at the household and feeder level. I'm going to be assigning load profiles based on CREST type modeling simulation. I've got real weather data for PV and electric heat pump simulations, which I can use to build up demand profiles for substations and houses and such. I'll then simulate the network, see what problems we have with voltages, thermal violations, reverse power flow, leveling, and then add storage in various amounts to see how that affects the quantity required to provide these services, and see how this changes with different amounts of PV and electric heat. So that's pretty much the lot for me.
Can I ask you to give an opinion on sort of the future of PV, terrestrial PV, and how that's going to impact?
Okay, so we'll look at the scenarios I've read suggest that from pessimistic to optimistic scenarios, we could look at anywhere between a 15% penetration in the next 20 or 25 years to a 35% penetration. So on shorter urban feeders, that might not be so much an issue. We might not need the storage even to provide voltage support. On longer feeders with a lot of customers, we start to see problems at fairly low penetrations with voltage imbalances and steady state voltage issues. So the use of storage it's got its competitors. You can use them on load tap changers, which do similar thing. Problem is if you've got an imbalance of PV across different feeders and different phases, that might not be the answer. Also, if you decide to use tap changers on the low voltage networks, what effect does that have on the voltages on the next network up, and if they tap change? It gets a bit complicated. So I'm looking to sort of analyse all of these different scenarios as I go along.
That was an amazing answer.
No problem, thanks.